Machine Learning and Cybersecurity, Transforming Digital Protection. Welcome, everyone. Today, we're diving into the fascinating world of machine learning and cybersecurity. If you're new to this topic, don't worry. By the end of this video, you'll have a solid understanding of how these powerful technologies are transforming the way we protect our digital assets. So grab a cup of coffee and let's get started. First, let's talk about what machine learning is and why it's so important in cybersecurity. Machine learning is a subset of artificial intelligence that allows computers to learn from data and make decisions or predictions without being explicitly programmed. In the context of cybersecurity, machine learning models can help detect and respond to threats more quickly and accurately than traditional methods. Cybersecurity has always been a cat-and-mouse game. As security systems become more sophisticated, so do the threats. But with the rise of machine learning, we're seeing a new era in which security systems can adapt and evolve faster than ever before. This is crucial because the digital landscape is constantly changing and new threats emerge every day. Now, let's break down the different types of machine learning models used in cybersecurity. There are three main categories: supervised learning, unsupervised learning, and reinforcement learning. Each has its own strengths and is used for different security tasks. Supervised learning. This is the most common type of machine learning in cybersecurity. Supervised learning models are trained using labeled data, which means the data comes with tags that indicate what the correct output should be. For example, a dataset might contain emails labeled as spam or not spam. The model learns from these labels to identify spam emails in the future. Supervised learning is great for tasks like intrusion detection, where the model can learn from past examples of attacks to recognize new, similar threats. However, it relies heavily on having a large, accurate dataset of labeled examples, which can be a challenge to obtain. Unsupervised learning model. Unlike supervised learning, unsupervised learning models don't require labeled data. Instead, they analyze patterns and structures in the data to identify anomalies or outliers. This is particularly useful in cybersecurity for tasks like anomaly detection, where the goal is to spot unusual behavior that could indicate a security threat. Unsupervised learning is great for catching threats that we haven't seen before because it doesn't rely on pre-existing labels. However, it can also generate a lot of false positives, which can be a downside. Reinforcement learning. This is a more advanced type of machine learning where the model learns by interacting with an environment. It receives rewards for making correct decisions and penalties for incorrect ones. In cybersecurity, reinforcement learning can be used to teach models how to respond to threats in real time, making them more dynamic and adaptive. Reinforcement learning is particularly useful for tasks like automated response and mitigation, where the model needs to make quick decisions and adapt to changing conditions. However, it can be complex to set up and requires a lot of computational resources. Now that we understand the different types of machine learning models, let's dive into how they are trained for security tasks. The process involves several key steps: data collection, data preparation, model training, and model evaluation. Data collection. The first step is to gather a large data set of security-related information. This can include network logs, system events, user behavior data, and more. The quality and quantity of data are crucial because the model's performance depends on what it learns from this data. Data preparation. Once we have the data, we need to clean it and prepare it for training. This involves removing irrelevant or duplicate data, normalizing the data, and sometimes even creating new features that the model can use to make better predictions. Model training. The next step is to train the model using the prepared data. For supervised learning, this means feeding the model examples of threats and non-threats so it can learn to distinguish between them. For unsupervised learning, the model looks for patterns and anomalies in the data. And for reinforcement learning, the model interacts with a simulated environment to learn the best actions to take. Model evaluation. After training, the model is tested using a separate dataset to evaluate its performance. This helps us understand how well the model can generalize to new, unseen data. We look at metrics like accuracy, precision, recall, and F, one score to determine the model's effectiveness. Once the model is trained and evaluated, it's ready to be deployed in a real-world security system. But the training doesn't stop there. The model continues to learn and improve over time as it processes new data and receives feedback from security experts. Now, let's talk about how machine learning models are integrated into existing security infrastructure. The goal is to enhance the security system's capabilities without disrupting its operations. Integration with existing systems. Machine learning models can be integrated with various security components, such as firewalls, intrusion detection systems, and user behavior analytics. For example, a model trained to detect phishing attempts can be integrated with an email filtering system to automatically block suspicious emails. Real-time threat detection. One of the biggest advantages of machine learning in cybersecurity is its ability to detect threats in real time. When a model identifies a potential threat, it can send an alert to a security analyst who can then take immediate action. This can significantly reduce the time it takes to respond to an attack. Continuous monitoring and improvement. Security systems with machine learning models need to be continuously monitored and updated. This involves collecting new data, retraining the model, and fine-tuning its parameters to improve performance. The system can also use feedback from security analysts to help the model learn and adapt. Human-machine collaboration. Machine learning models are powerful, but they are not a replacement for human expertise. Security analysts still play a crucial role in investigating threats, confirming alerts, and taking action. The best security systems are those that combine the strengths of both humans and machines. While machine learning offers many benefits in cybersecurity, it's not without its challenges and limitations. Let's take a closer look at some of the key issues. Data quality and quantity. The performance of machine learning models is heavily dependent on the quality and quantity of data they are trained on. Poor data can lead to inaccurate predictions and false positives. Collecting enough high-quality data can be a significant challenge, especially for new or rare threats. Overfitting and underfitting. Overfitting occurs when a model is too specific and performs well on the training data, but poorly on new, unseen data. Underfitting is the opposite, where the model is too general and doesn't capture the nuances of the data. Both issues can be problematic in cybersecurity, where the goal is to accurately detect threats in a wide range of scenarios. Adversarial attacks. Cyber attackers are always looking for ways to exploit vulnerabilities in security systems. One tactic is to use adversarial attacks, where they manipulate the data to trick the machine learning model into making incorrect decisions. This is a significant concern, and researchers are working on ways to make models more robust against such attacks. False positives and false negatives. Machine learning models can sometimes generate false positives, where they incorrectly flag benign activities as threats, or false negatives, where they fail to detect actual threats. Balancing these two types of errors is a critical challenge in cybersecurity. Too many false positives can lead to alert fatigue, while false negatives can leave systems vulnerable to attacks. Scalability and resource constraints. Implementing machine learning models in large-scale security systems can be computationally intensive and resource-heavy. Security teams need to ensure that the system can handle the load without compromising performance or introducing new vulnerabilities. Despite these challenges, the benefits of machine learning in cybersecurity are undeniable. By continuously monitoring, improving, and collaborating with human experts, we can build more resilient and adaptive security systems that stay one step ahead of potential threats. In conclusion, machine learning is a game changer in cybersecurity. It allows us to detect and respond to threats more efficiently and effectively than ever before. But it's important to understand the different types of models, the training process, and the challenges they face. By doing so, we can build more robust and intelligent security systems that protect our digital world. Thanks for watching! If you found this video helpful, don't forget to like, share, and subscribe for more content on cybersecurity and technology. Stay safe out there, and we'll see you in the next video!